Hello children, welcome to aimsindia's online classes. In today's video, from mathematics subject, sequences and series topic we are going to discuss. So here children, let's start with the sequence. So sequence means it is a set of numbers which are written in some particular order. A group of numbers or set of numbers, if you are writing in some particular order, for example, like 1, 3, 5, 7, 9. This is a group of numbers. So they are having some order. So in which order we have written them? They are all odd numbers. They are all odd numbers starting from 1. The difference between each two elements is plus 2. 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. So like this set of numbers, group of numbers, having a particular rule is called as sequence. So this group of numbers is an example of sequence of odd numbers. Sequence of odd numbers. So in another way, we can name it as a sequence of odd numbers, or in another way, it is a sequence starting with 1, and each succeeding number will be obtained by adding plus 2 to the previous number. Plus 2 to the previous number. Like that, it can be defined into two types of sequences, categorized into two types of sequences. Set of odd numbers, one sequence. Set of numbers which are formed by adding plus 2 to the previous number. Like that, we can name it as any kind of sequence. Suppose, let's see another sequence. 1, 4, 9, 16, 25. So here, 1 can be written as 1 square. 1 can be written as 1 square. 4 can be written as 2 square. 9 can be written as 3 square. 16 can be written as 4 square. 25 can be written as 5 square. So 1 square, 2 square, 3 square, 4 square, 5 square. Like that, we can write the given sequence as squares of natural numbers. So this is a sequence of square numbers. This is a sequence of square numbers starting from 1. Or if you see another sequence, so 1 minus 1, 1 minus 1, 1 minus 1. So this is also a sequence alternating between 1 and minus 1. Alternating between 1 and minus 1. So first 1 will come, next minus 1, next 1, next minus 1, 1, minus 1. Like that, 1 and minus 1 will alternate. Okay. So in each case, we have written some dots at the end of the sequence, which indicates this sequence will continue. This sequence will continue with the same manner. So it is an infinite sequence. It is an infinite sequence. So the dots represented at the end of the sequence, so they represent that it is an infinite sequence and it goes on forever in the same manner with the same relation. So that is about sequences, children. So on the other hand, not only infinite sequences, we can also have finite sequences. Finite sequences. Suppose the numbers like 1359, the group of numbers like 1359, 1359 is just a finite sequence. Finite sequence having only 4 numbers. The sequence ended with 4 numbers. Or the group of numbers 14916. It is also a finite sequence having just 4 numbers, 4 elements. So, like that, we can have infinite sequences. If we represent dots, it means that it is an infinite sequence and it goes on forever. If there is no dot, mentioned after the last element, then we have to consider it as finite sequence. It is having only limited number of elements. Limited number of elements. So the numbers 1, 2, 3, 4, 5, 6 and so on, whenever we have dots, we can read it as and so on up to n. We have a group of numbers starting from 1, 2, 3, 4, 5, 6 and so on up to n. So actually, what does these numbers represent? The numbers starting from 1, they represent counting numbers. We use them for counting purposes. We use them for counting purposes. But in these numbers, we have included n. We have included n. So actually, now the question is it finite series or infinite series? Previously, what we have told, if we have dots, we have told that it is infinite. If there is no dot, we have told that it is finite. But here we are having dots, and at the end we have an element n. We have an element n. Now the question is it finite series or infinite series? So in this case, if we have dots and after that we have a element, another element, so then it should be considered as finite sequence. It's not infinite. It's finite sequence. So here the dots indicate that we have not written all the numbers up to n, only the beginning numbers we have written, and the next numbers will continue according to the same relation which is there for beginning numbers, and the numbers will continue up to the value of n. Okay, so here if we have n after the dots, then it tells that it is a finite sequence, and the last number will be n, So after the dots, there is no end element, then it is infinite sequence. But if there are no dots, it is finite sequence. But if there are dots and if there is end element, that is also finite sequence. So here, suppose here is a sequence. So 1, 1, 2, 3, 5, 8 dots. We have dots and there is no end element. So this is an infinite sequence where each term from the third term, each term from the third term is obtained by adding together the two previous terms. Suppose here 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8. These kind of special sequences, they are called as Fibonacci sequences. They pronounce it as Fibonacci like that, or we call it as Fibonacci sequence. So from third term onwards, here the first term, second term, we cannot establish the relation between the first two terms, but the third term, from third term onwards, we can establish the relation between the terms. The third term is obtained by adding the previous two terms. The fourth term is obtained by adding the previous two terms. Like that, we were able to establish the relation from the third term. So it is a special kind of sequence and it is called Fibonacci sequence. So we will study about this in later parts. So just we have introduced the sequence here, Fibonacci sequence. So actually we often use an algebraic notation for sequences. We call the first term as T1, term 1, second term as T2 and so on. And using the same notation, we write Tn to represent the nth term of the sequence. So T1, T2, T3 and so on up to Tn. Suppose if you have terms like this, then this group of terms will represent a finite sequence containing n terms. Containing n terms. So, and for Fibonacci sequence also, we have some other kind of representation. Let's see about that. So, this is the representation of all the elements of a group of numbers in the sequence, starting from T1, T2, T3 up to Tn. Suppose here, so if you take this, suppose this is the nth term, 8 is the nth term. So this is a Fibonacci sequence. Here, suppose 8 is the nth term, then the relation between the terms in Fibonacci sequence is given by what? Tn before term will be n minus 1 term. Suppose if it is fourth term, so first term, second term, third term, fourth term, fifth term, sixth term. If nth term is sixth term, then before term will be fifth term. Or if sixth term is nth term, Tn, then fifth term will be Tn minus 1. Then fourth term will be Tn minus 2. Now in this sequence, what is the value of Tn? Tn is the sum of Tn minus 1 plus Tn minus 2. So Tn is the sum of Tn minus 1, Tn minus 2. So which means nth term is obtained by adding the two previous terms. Nth term, not only nth term, any term in the Fibonacci sequence can be obtained by adding the previous two terms. So that's why Fibonacci sequence can be written in this manner. Sometimes not only T1, T2, sometimes we use U1, U2 and UN for representing the terms. Next slide. So now we have different types of sequences. So far what we have discussed, based on that, we can divide the sequences as per the number of elements which are present in any given sequence as. We can divide the sequence into finite sequences if they don't have dots, infinite sequences if they have dots at the end, and dots at the end, or if they have dots at the end and if they have end element, then it is a finite sequence, or Fibonacci sequence. Fibonacci sequence means if the third term is, or if any term is the sum of its previous two terms, it is called Fibonacci sequence. Like that, so far we have discussed some sequences types. So let's elaborate them one by one. So finite sequence. Finite sequence means a sequence in which the number of elements which are present in it is finite or countable. If the number of elements are finite or countable, then it is called finite sequence. So the total number of elements present in that finite sequence, it is called length of the finite sequence. Suppose 1, 2, 3, 4, ... and so on up to 90. So it is the finite sequence. So then the length of this finite sequence is 90, because starting from 1 to 90 we have 90 elements in that. So the length of this finite sequence is 90. Next. So infinite sequence. So a type of sequence which is not a finite sequence is called infinite. is called infinite. So for example, the sequence of successive quotients mentioned here mentioned above is an infinite sequence. 1 minute, children. Here, children, 1 minute. So the sequence, suppose if you take this sequence 2, 4, 6. So this is an infinite sequence because we have in this group of numbers we have 2, 4, 6 and so on. Here we have some dots. Means the relation between the numbers continues forever. It never ends. It never ends. So this group of numbers is called as a infinite sequence. Infinite sequence. So often it is possible to express a rule for this infinite sequence, and with the help of that rule we can find various terms of the sequence in terms of a formula. Suppose if you take this sequence 2, 4, 6, it is a sequence of even natural numbers. It is a sequence of even natural numbers where A1 first element is 2, which can be written as 2 into 1. A2 second element, which is 4, which can be written as 2 into 2. A3 third element, which can be written as 2 into 3. Means as it is third element, we are multiplying third element 3 with 2. Next, if you want fourth element, we have to multiply 4 with 2. 4 2 times 8 will come. If you want fifth element, we have to multiply 5 with 2. We will get 10. If you want 24th element, we have to multiply 24 with 2. We will get 48. Like that, with the help of the given terms in the infinite sequence, we can establish a relation between them, and we can have a algebraic formula for every term, and with the help of algebraic formula we can find the various terms of the sequence. That is about infinite series. So next, Fibonacci sequence. Fibonacci sequence means in some cases just by seeing the sequence we cannot establish the relation. There will be no invisible pattern just by seeing the sequence or just by observing the first two elements of the sequence. So for but there may be some hidden pattern. There may be some hidden pattern between them that we have to try to understand first. So though there is no visible pattern between the 1, 2 elements, but there may be some recurrence relation between the other terms if you compare all the terms. Suppose if you check all the terms, here A1, A2, first two elements are 1, and A3, which is A3 is 2, which is a sum of 1, 2, A1 plus A2, and A4, and A4 is 3, which is a sum of A2 and A3. A5 is 5, which is sum of A4 and A3. In the same way, An, we can have nth element An, which will be a sum of its previous term, An minus 1, its previous term, An minus 2. An minus 2. But here one condition we have to follow, because here n minus 1, n minus 2 is there. This n value should be greater than 2. N means number of terms. We should have at least 3. Greater than 2 means at least 3. So then only this relation we can apply. Suppose if n is 2, then here 2 minus 2, it will become 0. There will be no first term. between two terms, we cannot establish this kind of recurrence relation. So here, this kind of recurrence relation is possible only if and only if n is greater than 2. Number of elements are greater than 2. Then from the third element, we can observe one kind of recurrence relation. So this type of sequence is called Fibonacci sequence. Fibonacci sequence. Next one. Fibonacci sequence formula. If an is the nth term, an minus 1 will be its previous term, and an minus 2 is the term before the term an minus 1. Before the term an minus 1. So then an equal to sum of an minus 2 term and an minus 1 term, where n is greater than 2. Where n is greater than 2. This is the formula for Fibonacci sequence. Suppose if we have 2, 4, 6, 8 and so on, the nth term of this sequence can be written as okay. So up to here only, this Fibonacci sequence. Suppose if you see about this sequence 2, 4, 6, 8, then nth term of this sequence can be written as first term is 2, 2 into 1. Second term is 4, 2 into 2. Third term is 6, 2 into 6, 2 into 3. Fourth term is 8, 2 into 4. In the same way, nth term can be written as 2 into n. 2 into n, where n is the natural number. Suppose if you have a sequence like 135 and so on, 135 and so on. So the nth term is given by first term 2 into 1 minus 1. Second term 2 into 2, 4 minus 1. Third term 2 into 3, 6 minus 1. So nth term will be given by 2n minus 1. 2n minus 1, where n is the natural number. So this is an infinite series of even numbers. In this nth term can be written as an equal to 2n. And this is odd number series. In this nth term can be written as an equal to 2n minus 1. 2n minus 1. So this is about sequences, children. About series we can learn in our next video. So what we have learned, children, about sequence. About sequence we have learned. In sequence we have some types: finite, infinite, Fibonacci. Finite means number of elements we can count, and number of elements is called length of the finite sequence. Infinite means number of sequences we cannot count. We can establish a relationship between or algebraic formula between the terms. With the help of that formula, we can find any term in the sequence or various terms in the sequence. Fibonacci sequence. Fibonacci sequence means there will be no invisible, there will be no visible pattern. Just by seeing the sequence, we cannot observe the relation between the terms, but there will be a recurrence relation between them, which is given by an equal to an minus 2 plus an minus 1, where n should be greater than 2. Okay, children. So remaining topics we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.